Okay, so let's start our enterprise application development topics. Now we move on to our second topic, remote method invocation. Right, so remote method invocation means in enterprise applications, we need to integrate different systems together, right? So not entire system is in one machine. So that is for small applications, not for enterprise applications. Enterprise applications often you need to communicate with other systems, maybe different part of the systems, same systems in different servers. Sometimes web server is in one machine and application server is another machine. Sometimes internally your web server need to communicate with database server. Right? Maybe we involved in this, or maybe your servers need to communicate remotely with other machines, other servers. Okay. So this topic is all about how to do this remote method invocations. So if you look at the lowest level communication uh, from machine to machine is called socket communication. Socket communication. So that is the lowest level, right? So then little bit higher level, we have the remote method invocation. It's abstract approach, which is little bit convenient than socket programming. And on top of that, we have web services, microservices, and so on. That is how it works. So therefore, remote method invocation, most of the time we will not do as developers if you are doing enterprise application development. But this is something the servers do. Your web server communicate with database server, your application server, web server communicate with application server, and so on. Right? So therefore, we don't need to do this type of programming much, but at least we must aware that internally these things happens when we use web services and so on. Okay. Right. So therefore, it's good to know the concept. Remember again, the idea is give you the confidence. Otherwise, there are a lot of mysteries. Right? A lot of mysteries, but you don't know what happens. You try to use the high level concept. Maybe you will be using web services, but you must know what is happening inside, underneath. Okay. And if you are into the very technical track, like you are, say, if you are into something like, say, you got a job as a software engineer in WSO2. So their main task is developing these servers. So then, of course, you need to go and work in this level of programming. Okay, because then your job is not developing application, rather developing these infrastructure servers. So then definitely this kind of topics is your basic competencies. But others, you need to understand these concepts so that you know what is happening inside. Okay, right. So we will look at what is a remote procedure call, uh, some practical usages of remote procedure calls, so RPCs, challenges, different technologies, and we'll do a practical session using Java RMI, which is Java way of doing remote procedure calls, right? Practical sessions, okay? Right. So what is remote procedure call? Now remember when we discussed Java in semester one, uh, in structured programming, one method can call another method. Say you have method X. So inside method X, you can call method Y. Say there's another method called method Y. So then control come to Y and then it returns. So then the rest of your X. So that is local method call. So the methods called is in the same machine, same JVM, if it is Java. Basically, it's in the same machine, right? So remote procedure call means one method in one machine calls, see that means you are running a program, that program calls another method in another machine. And then it returns, then you continue your call. So that is remote procedure call. If you directly call that method remotely, other rather than calling it using web service or something like that. So that is higher level of abstraction. But here you directly call the method in other machine, which is in a remote machine. Okay, remote procedure call. Is it clear? Okay. So using the network. So these things are internally used heavily in client server communication, peer-to-peer communication, web service calls, and so on internally. Right, internally. So hide in the complexity of RPC, it exposes it as a web service. But now we are going to look at how to do the RPC call. Okay. Right. What are the challenges? So there can be some issues. Maybe these machines are using different technologies. Maybe this is your Java program. This is a C program. So can my Java program call the C program methods? Or can my Python program call Java program? So then there can be data type differences. Maybe that particular language doesn't support a particular data type. So it's a Java data type which is not available in Python. So then the reliability, because you are calling through network. So there can be some network issues, security issues, right? It's reliability issues, slow responses, slow network, and error handling. Because maybe when you call, the error happens in the other machine. Then how to report that error? Maybe error is during the transmission in the network. How to report that error? How does the caller knows there's an error issue in network? There's an issue in the other machine. So that make remote procedure calls more complex than local calls. And there are different technologies developed to overcome these challenges. Overcome these challenges. So one of the very first technology was COBA, Common Object Request Broker Architecture. COBA. So the idea was let programs running in different machines call methods of other machines, other programs running on other machines. So COBA was very general architecture. So they want to make sure that it's technology neutral. That is why common, technology neutral. So your program can be C, this program can be Java or something else. But it was very complicated architecture. It was not much use at that time also. These days, of course, we don't talk about COBA anymore. But just remember that is the first the big technology related to remote procedure call. Though we are not going to discuss about it, but you need to aware that this is another technology, though we don't use much these days. But the good news about COBA is it's technology neutral. Technology neutral. So then Java came up with a remote method invocation technology called Java RMI. RMI means remote method invocation. So the good news is it is simpler than COBA. But the bad news is it's communication between Java programs in different machines. So Java program running here, Java program running here, Java program running here. You can use RMI. Maybe call this method, get the return, call this method, get the response, and so on. But it's much simpler than COBA. And data type issues are also not there because it's all Java. Okay. And there's a uniqueness, right? The way exceptions are handled and sort of things. So therefore, it's much more simpler approach, but the limitation is only within the same technology. So similarly, Microsoft also came up with their own remote method technology called COM or DCOM, Distributed Component Object Model. But again, the good news is it's simpler. The bad news is simpler than COBA. Again, the bad news is it's within Microsoft technologies, just like Java RMI. Okay. Right. So COBA, Java RMI, DCOM. COBA is a general technology. Java RMI and DCOM are technology specific technologies. So then there are some more technologies like gRPC generated by Google, Apache Thrift. Okay, so those are again common technologies. Remember, the COBA was little bit older technology, so therefore no one is interested much about COBA right now. Java RMI and DCOM is good, but within the same technology. So the modern alternative for COBA is if you are looking for cross-tech platform, cross-technology, there are some other alternatives right now. What are those? gRPC or the Google Remote Procedure Call, Apache Thrift. Apache is again open source technology provider. Okay. So those are there. But in our discussion, we will only concentrate on uh, Java RMI. Java RMI because it's a very good starting point before moving to cross-platform technologies like this. Okay. And also you are already familiar with Java from semester one. Right. As I already mentioned, the idea behind remote procedure call is a program in one machine calls a program or remote procedure in another machine through network. Okay. So then we use a bit of a terminology here. Say this is one machine, this is the other machine, and program in this machine calls a program or the method procedure in the other machine and get the response. So then this is called the server because this machine called this machine or procedure in this machine. So therefore this is server and this is client. Caller is client, server who is serving the method called is called server. Okay. So then we use another concept. Client will not directly call the server. Rather, client will call something called stubs in the client machine, and the stubs will call the skeletons in the server machine, and the skeleton will call the actual method in the server, and then the return goes to the skeleton. Skeleton give it to the stubs, and stubs give it to the client program. So that is how it really happens. Okay.
Client machine.
Any question? No?
The stop client machine.
I think your connectivity is not very clear. Can you repeat it? I can't properly hear what you are telling.
Subsign client machine or server.
Stubs are in client machine, skeletons are in the server machine. But sometimes we call both as stubs as well. Okay, right. I'll get back to that in next slides. Okay, right. So this is your client machine. Client machine called the client stub. Okay, then client stub communicate through the network to the server stub, or sometimes we call it server skeleton. Right. So then server stub or server skeleton call the server, and server gives you the result to the server stub. Server stub give it to the client stub, and client stub give it back to the client. Okay. So client side, we call it stub. Server side, we call it skeleton. But in some cases, some people, they call both this stub skeleton also, they we call it stub. Right? So sometimes we say client stub and server stub. Some people use that terminology. Some others say client stub, server skeleton. Okay, so that is why the confusion is. Some people say both stubs. Some people say client stub, server skeleton. Okay, right. I will be more using client stub and server skeleton, but some people they just use stub for both stubs and skeleton. Okay. Right. So therefore, either you can call this client stub. Of course, this is always client stub. This is either server stub or you can say server skeleton. Okay. Right. So then someone will ask, why do we need these stubs and skeletons? Okay. So stubs and skeletons are something we generate. We generate through tools. So the idea is if client directly call the server, that is client directly call the server through network like this, the things are more complicated because it's a remote call. Okay. So therefore, to make it easy, we generate something called client stubs and server skeleton. So in other words, client stubs and server stubs. Okay. So then client call the client stub. Because client stubs are in the client machine, it's a normal call. It's a local call. So therefore, your program is doing a local call to the client stub. Then client stub remotely call the server skeleton or the server stub. Then server stub or the server skeleton do a local call to the server. You can see local call to the server. And you get the local return to the stub or the skeleton in this case. And then the server skeleton give it back to the client stub. And then client stub give it back to the client. So therefore, this call and this call, these are sort of a local calls. Local calls. Local calls means in the same machine. So therefore, when you are writing the remote procedure call, you feel like you are doing a local call. Right? Because the complexity is handled by these stubs and skeletons. Stubs and skeleton, which are generated by tool. In our case, our tool is Java tool, Java JDK tools. Right? So that is the idea. Otherwise, we need to write complicated code. That is the stuff that client stubs are doing, we need to write in the client machine. The stuff that server skeleton is doing, we need to write it in the server machine or server application. But because stubs and skeletons are generated by the Java JDK, we can call it simple manner. And server can respond simple manner because server is communicating with server skeletons, client is communicating with client stubs. So that make our coding less complicated because more complicated things are handled by these generated codes. So that idea is to hide that complexity for the developers because otherwise it's too much coding for you, which is something you don't need to handle because it's sort of a boilerplate code. Boilerplate code කියන්නේ ඒක හැමතිස්සෙම එන්න ඕන කෝඩ් එකක්. ඒතකොට ඔයා ලියන්න මට වැඩි හොඳ දැන් කාට හරි කියලා ජෙනරේට් කරගන්න. That is the idea, right? So therefore, the idea is to make the server developers and client developers work simpler. Okay, simpler. Right. So what are the pros and cons of Java RMI? of course, Java RMI is simpler than COBA because COBA is to support multiple technologies. Java RMI is to support Java to Java communication. And the other thing is Java RMI is built-in supported by JDK. You don't need to install anything, any other software, any other package. If you have Java or JDK, already you have Java RMI. Okay. You don't even need a third-party libraries. Okay. And also it supports sending objects. Though we call it remote methods, actually it supports sending and receiving objects also. As parameters, you can send object, say account object, payment object. Remember, parameter can be object. So therefore, don't think that it is just structured programming, though we call it remote method invocation. It support object orientation. Okay. And your objects are serialized and sent. And if you return get an object as a return, it can be deserialized. So serialization, deserialization. We discussed about serialization and deserialization under uh, file handling in Java, semester one, right? File handling in Java. So that is how the objects are serialized and sent. And when you receive an object, you can deserialize. I have uploaded an example for that in your Google Classroom if you are interested in what is the serialization and if you have forgotten about serialization, deserialization, because we discussed that in semester one. Right, serialization revision. Okay. But it's not a must to understand. But if you are curious, so you can just look at this. Okay. Right. So therefore, yes, objects are supported by Java RMI. Okay. Right. So the cons is obviously uh, it's between Java to Java. Right? Between Java to Java. Right. So this is the difference between local methods call versus remote call. In local method, uh, it's in the same JVM. But in remote method call, it's in two different JVMs or two different machines or same machine, two JVM. Maybe one is in a virtual machine. Okay. So if you are calling from one machine, virtual machine to the other virtual machine in the same machine, that is also like remote method calls. Okay. Right. So this is the mechanism in more details. So you have the client machine. A client want to call a method call in the server machine. That is two different JVMs. So what we do is server need to, so there can be so many servers. So there must be a mechanism for client to identify or look up the servers or look up the remote procedures available. So how to do that? The server can publish your expose remote procedures to the what is called as Java RMI registry. Right? So the server can publish saying that, okay, I have a method which can be remotely called and I can respond. So you publish it to the Java RMI registry. So then clients can locate the possible remote procedure methods or call possible from lookup from the registry or Java RMI registry. Server publish it, client lookup. And if that particular method is available, it will say yes, it's available. So then the client can directly call the server through the skeleton. Then skeleton call the stubs and stubs call the server and so on. But once you locate the procedure from the registry, that's it. Then the client directly call the server through the skeletons and stubs. But before that, client must have generated the skeletons and server must have the stubs. Sorry, client must have generated the stubs, server must have the skeleton. So in other words, client must have the client stubs, server must have the server stubs. Okay. So registry is only to look up, right? Only to look up. So therefore, this is how it's work when calling. Client call the client stubs through networks. So basically, client stub call the network server skeletons. Server skeleton call the server, and the result going through like this. So therefore, client feel like it's doing a local call. Server feel like it's serving a local call because the complexity is handled by stubs and skeletons. So the two stubs. Okay, so that is the idea. Right. So these are the necessary components if you are doing a Java RMI call. So obviously you need the Java RMI registry, which must be available to both server and client because server publish, client query. So this can be a third party machine. Okay, or this can be what maybe in the server, or maybe in the client, or it's a third machine. So then you have the server machine which publish the server or the remote methods. So it must have the interface, implementation, and server skeletons. A client machine must have the client and client stubs, client code plus client stubs. Okay. And of course, the RMI registry can be in the server or client, or that is in a different machine. So RMI registry will say how to call your server skeletons. Okay. As long as server has published it to the RMI registry. So this is how it works in more detail. So same thing, right? මේ එකම කතන්දරේ මේ ආයෙ කියන්නේ මම. So client call the client stub. Then there's something called remote reference layer, which is not something we discuss on the OSI architecture because it's more technical stuff. It's a sub layer on top of the transport layer. Right? So it goes like this. So then the remote reference layer to the skeleton, from skeleton to the server. So then the return tree. Okay, return tree. So that is little bit more details. So remember, transport layer is above the network layer in networking. Network layer. So below that we have the logical link layer, physical layer. මේ network layer එකේ තමයි තියෙන්නේ IP, internet protocol. Transport layer is where you have the TCP and UDP. Sessions are handled by transport layer. Reliability. Network subject එකත් එක්ක මෙතන connectivity එකක් තියෙනවා පොඩි හරි. So the transport layer is the one that create end-to-end connections. අපි කියන්නේ ports තියෙන port to port connection එක කරන්නේ software level එකේ, not hardware level. Transport layer. End-to-end communication. Okay. Right. So in your server machine, because server is the one that going to respond, so serve method calls. So you need to have the server interface. Interface is the contract, right? So interface is the contract telling that I have this service. I have this method. So then you need to have the implementation. If you are saying I have this service, you must, if someone calls, you must give the response. Then you need to have the server skeleton so that your server call the skeleton or your skeleton call the server, and server give the response to the skeleton. So therefore, you must have the server interface, server implementation, and the skeleton. Okay, in the server side. Okay. So then, client side, you have the client interface, which is optional. So then the client implementation, that is your client program. Then the client stops, because then the client can call the client stop. So that stop will communicate with the server skeleton. Then now these are local call. And skeleton call the server implementation, local call, give the response. Then the skeleton give it back to the stop as a remote call, and stop give it back to the client as a local call. So here,
Excuse me, sir.
yes.
So what is the function of stub and skeleton? I didn't understand.
So stub and skeleton is doing that remote calls. Otherwise,
Oh.
the server and client need to do the remote call. So rather you do a local call to this client, client stub do the remote call to the skeleton, and these are generated code. Otherwise, you need to write this code. So so the stub and skeleton is doing the heavy work. Otherwise, you need to write that code. Okay, so that is why we need stub and skeleton. So that is why these are generated code for you. Okay, rather than you write it. Right. So therefore, this is the round trip. So this is where the remote method invocation. This is where the remote exceptions, security, and other things must be handled. Okay. Right. So then we use another word called marshalling and unmarshalling. Remember, we discussed about serialization and deserialization in semester 1. So serialization means when you have object, you convert that object to a binary level so that you can send it through the network. So another name for serialization is marshalling. Right? So either you can call it serialize object, or you can say you marshal that object so that you can send it through the network. Okay. So then when you get the response, you need to deserialize to get it back to object, or you can say you need to unmarshal to get it back to object. Say you are sending so maybe the method parameter has a, say this is a method, say process, you can send account A, and it return payment object. So then when you call, you need to send account object. When you call this, what you get is a payment object. Payment is a class, account is a class. So then you need, in the client side, you need to serialize or marshal account object and send it. Right? And in the server need to deserialize or unmarshal the account object so that it can process this method. Then it serialize or marshal the payment object and return. In the client, it must be deserialized or unmarshal so that it can get the payment object. Okay, so that is how it works. Right? So in both sides, serialization and deserialization can happen, or marshalling and unmarshalling can happen. So not only in one side. Okay. So serialization is another word for marshalling. Deserialization is another word for unmarshalling. So marshalling means convert object to a format that you can transmit through network. Unmarshalling or deserialization means when you get the response through network, you convert it back to a valid object. Java object, so that your program can use it like a normal object in your local JVM. Okay. So marshalling, unmarshalling, or you can call it serialization and deserialization. Even you can serialize a object to a file, save it, and then read that file and deserialize back to object. We did that kind of example in our, possibly we have done it in semester 1. Okay. Right. So therefore, client marshal it if there are any parameters which are object parameters. Okay. When you send the request, then server need to unmarshal it, the parameter object. Then the server can return, if server return object, it must marshal it. Then the client need to unmarshal the return object. But assume that the client is not sending objects, client is sending some primitive values. So then there's no need for marshalling here, right? No need to unmarshal here. Say the server is also returning primitive data like integer. So then no need to marshal, no need to unmarshal. But still it's a remote procedure call. But let's assume we don't send object, but server return an object. Then no need for marshalling because we are sending primitive parameters or no parameters. But the server send me an object, then there must be marshalling and unmarshalling. Okay. So sometimes no marshalling, unmarshalling at all is required. Sometimes if the parameters have object, so this need to be happen, but no need for this. But if the return has objects, no parameters are objects, so then no need for this, but this happen. But if your parameters also have objects and return is also objects, all these happens. Okay, all these happens. But these things are done by your skeletons and stubs, not by your code. So if you ask why you have stubs and skeletons, that is another stuff these are doing. Marshalling, unmarshalling if required. Marshalling, unmarshalling is not always required. It is required if either parameters are objects or the return types are object or both. Okay. Right. RMI register I already explained. So the server need to publish saying that I have this remote procedure so that anyone can call me remotely. So then client need to look up from the RMI registry and see whether it's available. If available, it will give you how to call it. So then client can directly call through stubs and skeletons in the respective machines. Okay. So this is high level what happens. Any questions? Right. So we are going to do a small code.
Does RMI registry always updated?
Yes, if server publish it, yes. If a server publish another method, don't another server publish, so then RMI registry is always up to date. It has the current entries, current entries. Okay. Right. So now we are going to do a small code example, but only the thing is, rather than using two machines, my client and server is going to be the same machine, and my RMI registry is also going to be run in the same machine, right? So therefore, I can use something like localhost rather than the IP address, but it works even in network environment. Only thing is, then you need to use the correct IP address. Then your client you need to run in one machine, server code you need to run in other machine or call it in the other machine. Or even you can have RMI registry running in another machine, but all line must be in the same network. Or machines must be interconnected. But for simplicity, I'm going to do it in the same machine, but I'm going to call it using RMI. Okay, RMI. Uh, right, so these are the codes that are going to be client machine. I'm going to have two classes. Okay, let's first discuss the server. In the server machine, for me, machine is a folder because I'm using the same machine. I will be using one folder as the server, another folder as the client. Okay, right. So I'm going to have my serve.class. Of course, it can be anything you like, right? Names. For this example, then my serve implementation, that is the server implementation and the server interface. Okay. So this side you are going to have your client class and my serve class, and I'm going to start my RMI registry as well. Right. So this is the server interface. Server interface. So server interface is a Java interface. You know that Java interface is a contract for polymorphism. Interface can have method signatures, but no implementation. You can't have implementation. So in my server interface, let's call it my server or whatever. You can even call it ABC. It must extend the Java interface called remote, which is in Java RMI registry. So therefore, make sure you import it. So if you want to expose your methods as a remote methods, make sure your class extends the remote interface. Sorry, your interface extend the remote interface, which is a Java interface. Okay. It's a marker interface. Actually, remote interface has no methods. It's a marker interface. Marker interface means it's an interface, but that interface doesn't provide any method signatures. Okay. So therefore, if someone is implementing myserve class in interface, they just need to implement this method because remote interface has no method signatures. Okay. It's a marker interface, blank interface. Right. So that is the first thing you need. So I will show you the code now because I have already the code with me. Say D code. Right. So I have two folders rather than two virtual machines or two machines, server and client. So in server folder, I have, let me delete the class files so that I can compile it again. Right. So I have an interface. Okay, this class also I delete. And so these are the three files. So the first one is what? My serve Java. That is my interface class. Server interface. Right. Extend remote interface. So therefore I have to import this. Then you can write whatever the methods you are going to provide. You can have any method signatures. Right. You can have any method signatures here. In my case, I have a method called doCalc, which take two integers as parameters, and I'm going to give you a return value. Maybe I will add these two numbers. If you send 5 and 10, I will return it as 15. Because if you are going to use this as a remote method, make sure your method throws remote exception, which is again an built-in Java exception in Java RMI registry. Sorry, Java RMI package. So either you can say import Java RMI star or individually import these two this class and this interface. That's it. Because this is an interface, right? You can have any number of method signatures, uh, but do not implement because it's an interface, right? So that is a contract. So this is what we are telling to the RMI registry. I have these methods, right? I have these methods. This is the contract. Okay. Is it clear? Right. So then you need to implement it. So that means this is your interface. This is the method that you are promising in this interface, saying that I am going to implement this. So therefore now you need to implement it. In my case, I'm just giving the sum, because any complicated thing you can do here. Right? We don't care. Maybe you can connect to databases or whatever you want, you can do here. Okay. So in this case, because our task is just calling a remote method, I just send the sum of the two parameters you are sending, because it says return int. Okay. Right. So that is what my serve implemented. It can be any name. It can be any name. So it's written in the sum. Okay. So that is my server interface, server implementation. Right. So then you need to run and code another class, that is server application class. So basically you are going to write a small server, like so usually we use something like Apache web server, that kind of a server, right? So rather than, we are going to write a small server now. Actually, this is exactly what we do in web development also, right? Node.js. So that is why when you use Node.js, you don't need a server, right? So same concept in Java. So you write a small Java server, because this is going to be your server, right? So you can give it any name, right? Any name. But here we implement our server implementation. Remember that class was my server implementation, which has the implementation of that particular method. Okay. So there we have a main method, because this is a normal Java class that I'm going to run. In the main method, this is a blank constructor. Of course, constructor is not a must. We create an object of my server implementation. That is the other code. Right. Let me open that. Right. So there we create an object of this particular code. This particular code class. Okay. So then you need to bind this to the RMI registry. So if the RMI registry is running in your machine, you can bind it to the local, say in localhost. Otherwise, you need to give the IP address. Okay. So that is, you create an object of your server and bind it to the RMI registry. Okay. So then we are just giving a console output saying server is ready. Okay. Or if there's exception binding, that means if the RMI registry is not running, there will be exception when we try to bind it to this registry. So then we will say what is the exception is. Okay. So in my case, everything is in the same machine. So therefore it is localhost. And we bind it to the port number 500, which is usually not used by any other applications. Okay. And this is the name we use. So you can give it any name. So here we call it myserve. Okay. Right. So that is the server side. So server side, now we can compile also. So now you need to compile these codes. Only thing is I'm using the same machine, but you can do these things in one machine and whatever the classes in client in the other machine. Okay. Right. So I'll take a command line. I'll copy paste the path. So I first go to D, C, D. I will share the code at the end. Right. So now I need to compile these code because these are all Java, these remote exception and all these classes are already available in JDK. You don't need to install anything. If you have only prerequisite is you have JDK, whatever the JDK you are having. Okay. Right. So now I'm going to compile these things. You can either compile one by one, Java C, or you can compile all the classes together. Just say star.java. Okay, Java C, star.java. That is compile all the .java files. Okay, right. So no error means, no message means it has been compiled. Now you can see the task files. So that is what you are supposed to do in the server machine. Okay. So now let's get back to the client. So this should be in a different machine in reality, but I just have this same different folder. Okay. And first I will delete the classes. Right. So there first you need the client code, right? I will show it using the code itself. Right. So there again, you can see there's a main method. So that means we are going to just run it because this is our client that call that serve method. Okay. Serve method. In the exam, they don't ask about coding. Okay. Don't worry. Don't worry, right? Don't memorize these codes. But you must know the structure. Which one is your client stuff? Which one is your server skeleton? Right? So what are the important classes that you need to extend, implement? What kind of exceptions you can get? Okay. Right. So this is my client machine, client program. It has a main method so that I can run this class. Then it will run this main method, normal main method. So there first we look at, first we get the registry, RMI registry, assuming RMI registry is running. Okay. So therefore, before running the client, we will make sure that the RMI registry is also running. Okay. I will tell you how to run the RMI registry. So you get the registry, then you look up your server. Remember the same thing. Local host because my RMI registry is going to be run in my same machine. Otherwise, whatever the IP address of that RMI registry. Say your RMI registry is running in a third machine. So then here that IP address. Then here also that IP address. Because you are binding. Here you are binding. So then give that IP address. So that because RMI registry may be running in another machine with IP address, say 125.39.50. So then both cases you need to have the same IP address and the same port number. So RMI registry by default, we default port is 5000, which is usually in other programs don't use. And the same name because this is, we are looking up the same server. So if this is XYZ, this must also be XYZ. Okay. Right. So then we are creating a system scan object because we are going to input data from in the command line. So this is nothing to do with the remote method invocation because we are going to use the scan object to take some input from the command line. So we let the user to input X and Y. We convert it to int and take to our local variables. This is nothing fancy. This is our normal Java programming. Okay. So then when you look up, what you get is the stub. What you get is the stub. Okay. That stub you can cast it to my serve. then you just call it like a normal call, local call, right? You just call it like a normal call because you have already taken X and Y from the user. Maybe those are 5 and 10. Now you just call it and remember that method is supposed to return an int. So therefore you just take the return value to the integer and then we print the return value. And you need to write it in a try-catch block because these operations return can throw exceptions. Either you can catch the specific exceptions or you just catch exception because exception is the superclass of all the checked exceptions. Now the good news is for you it's just a normal local call. So it's like normal call, but actually you are calling through your client's stubs. Okay, client stub, or you can call it server stub, but actually a client stub called the server stub. Okay. So therefore, now in your client side, you need another class. So this is your client class. So you need the same class or the same interface because this is the contract, right? So this is the same code. We write it in the server. Remember, in the server also we have that interface, myserv. This is just copy it and put it into the client also because that is our contract. That is our contract because we are referring to it in our client code. So once you look up, what you get is myserv object, but actually what you get is the stub object. And that's it. That's it. So now you can compile the client code as well. I will take another command line. CMD. Go to D because I am having those in D drive. And CD into the client folder. Now I'm going to compile my client, this stub interface class and the my real client with the main method. Okay. So I'm going to do both together. I will just say Java C star.java. Right. No messages means successfully compiled. Okay. Right. So now I need to do is run my server. Remember, this is my server command, run my server. When I run my server, before running my server, I need to start my RMI registry because running a server means binding that to the registry, publishing it to the registry. So therefore, the first thing I need to do is start my RMI registry. Okay. So make sure you start the RMI registry from the same folder because now in our case, the folder is like the machine because, okay. So therefore, in this again, go back to the server folder in your command line and start the RMI registry. How to start RMI registry? There's a command. Everything is explained here. In Linux, RMI registry command, but since I'm using Windows, start RMI registry. Again, you don't need any other software. Just the JDK is enough. JDK has the RMI registry tool. Start RMI registry. Make sure you have the Java path variable set to your bin folder. Of course, otherwise you can't even compile. Right. Start RMI registry. So that will simply start the RMI registry. Which is a tool in Java JDK. Okay. It will open another command line. Don't close this command line. So this command line is open means Java RMI registry service is now running. So your server is also available. Now we have 3 command prompts, one for server, one for client. And because I started the RMI registry, there's another command, don't close it. You close that command prompt means you have closed the RMI registry, stop the RMI registry. And now I can run the server. So what does the server do? Server will just bind the, right? Server will bind your method, my server implementation to the RMI registry with the name of my server. So because though the registry is running, still registry doesn't know that this particular method is available for remote calls. So therefore now your task is run this particular class, run, because it's a main method. This is a mini server, right? So just run your server in the server folder, not client folder, server folder, Java serve, right? What is class name? Serve. Yeah, server. 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 Remember, it's case sensitive. Right. So now it says server is ready. That means it has bound the remote method to the RMI registry, or it has published it to the RMI registry, and it is now waiting. If someone calls remotely, it's ready to serve. It's ready. So basically, I run this particular class main method. Okay, that is why it says server is ready. Okay. And now the client can call it. Client can call it. So that means now you need to run the client class from the client folder. Right? Client Java. So what does the client do? Assuming that the RMI registry is running, of course, now RMI registry is running, right? So this command line is open, right? So it will look up this particular remote method. Of course, we have already published it in the server by running the server. So then it will ask the user to enter X and Y. If it can't find it, there will be exception. Then it will ask the user to enter X and Y and then call this my server stub with the two parameters that you get it from the user. And it should get the return value. You call it like a local, but actually it will be a remote call if it is in a different machine. And then the return value will be published, print to the system out printed. So therefore, let's run the client Java file in the client. Okay, Java, we have already compiled client. Right, so it says end text. That means this is successful. That is why it comes to this line. So that means it has found the service from the remote method from the RMI registry. Otherwise, it won't come to this line. It will go to the catch. Right. So now I'm going to enter value for X. Let's say 90 or 80. Say Y, I will say 40. So then the return value must be 120. Okay. And it says sum is 120. Okay. Sum is 120. That is clients. And if you want here, you can write a system out println as well in the server implementation. So that whenever someone calls, you can see it. Okay. For example, here if you write a system out println, so whenever calls in the other console, you should see that also, right? So that you can do it as example. So as exercise, you can add another method here. So then first add that also to the interface. Add another method to the interface. Make sure that method also throw remote exception. Then implement that also. Okay, and also make sure you write some system out println here so that you can see it in the server console. So then from the client, right, from the client, you call that in your client machine, you call the new method as well. So here we call the do calc, maybe do my other calc or whatever. Okay. And if you are really interested, see whether you can send object here or return object or send object and return object. That now this example doesn't use marshalling and unmarshalling or serialization, deserialization. Why? Because my methods parameters are primitive, return value is a primitive, right? So if a parameter is object or set of objects and return type is object or both, then you are using marshalling and unmarshalling. So the only thing is then say you are sending a account object. So then make sure that account class implement the serializable interface. It's a marker interface. If the return is say something like payment, make sure the payment object implement the serializable interface. It's a mark interface. You don't need to do anything at all. So then you can get the say payment object. You can send say order objects. So if you are interested, do it as exercise. Right? Get the help from ChatGPT or whatever. Right? So you can ask ChatGPT. Because I don't know, I don't do that for you. Okay. It is for if you are curious, right? It's not going to be important for the exam, but I don't know if the examiner can ask about marshalling and unmarshalling. Right? So generate a simple program that use Java RMI. Let's first say generate a simple program that use Java RMI, both client and server. Okay. Right. So then it will generate a similar example. Okay. Right. So you can see say hello, extend remote. Then this is the server implementation. Now the say hello is implemented. It just return a string. Right? It just return a string. So then the client server class, it create the server that is it bind to the RMI registry. Right? So it use different code, slightly different code. That's fine. Right? It's use rebind rather than bind. Rebind means if it is already bind, rebind it. Okay, so slightly different, but it's okay. So then the client's code, get the registry, do the lookup. So the lookup is doing in a simple manner rather than localhost, right? So then you call it using your stub. Okay. So this is similar, and make sure you compile it using javac start.java, start the server, right? Take another terminal and run your client. Okay. And so on. I think it's using by built-in Java RMI registry. You don't need to start the RMI registry. I think so. Okay. Yeah, I think your server is running the RMI registry in this case. Okay, so you don't need to separately run it. Okay. Then you can ask modify the code example to send or return an object. Now it is going to use marshalling and unmarshalling. That is serializable interfaces. I am not asking it to send parameters object, just return object, because otherwise it will be too complicated. Okay. Then you can say, okay, make parameters also object. Okay. Right. So returning object is where Java RMI become more powerful. We will return custom object from the server to the client. Okay. Now it's going to return a student object. Remember, if you are set return using that object or you pass it as a parameter for remote procedure calls, make sure you implement the serializable interface. Serializable is a mark interface. That means that interface has no method. So therefore, you don't need to implement anything. Right? So therefore, this is just a normal class, nothing else. Only thing is you just need to say it's implement serializable. And now you can use student as a return object in your remote call. Right? So now you can see this particular method return a student object. Earlier it returned a string. Right? So now it create a new student object and return it. කෙලින් මෙයා object එක හදලා return කළා දාලා line එකේ. So the server is now calling the method, right? So this is binding or rebinding. Yeah, rebinding use करे, මම use करे binding. හරි? එකට කවන්නේ. So then client in the return වෙන්නේ. So this is getting the stuff from the registry and calling the get student. Now you can see the return is student. Return is student. Now the remote method return a student object. But for you, it's still a normal, like a local call. But because now the return is an object, now in the server, marshalling happen or serialization happen. Serialize the student object and send it to the network. And in the client machine, unmarshalling or deserialization must happen so that you can get the student object back. Because you get that student object through the network. Because this method is in another machine. So therefore, now in the return trip, marshalling happens in the server, unmarshalling happens in the client. But if your method parameters are also objects, so then in the client, marshalling happens, in the server, unmarshalling happens. If you have both parameters and return as object, then client also marshalling happen, server unmarshalling, then again server marshalling in the return and in client unmarshalling. So you can ask ChatGPT to use both objects in both parameters and return types as well. But you don't have to do anything. You just make sure that those objects implements the serializable interface. That's it you are supposed to do. Okay. So marshalling and unmarshalling is something that is done by internally. That is something done internally by your stubs and skeletons or your JDK. Okay. Right. Do you have any questions? Any questions? The way it bind is slightly different from the way I did it. Right. You can see it says local registry, create a registry, because I did it in a more general manner. Right. I just call the get registry, but here ChatGPT has generated something called create registry. Both approaches work. I think this approach is the better new approach for the new JDK. Okay, so maybe you can use this. Okay. Right. Any questions? Any questions? Because that's it about Java remote method invocation. Okay. Right. So if you don't have any questions, we'll do a few past paper questions. Okay. Right. So 2023, paper 2, question 1E. Illustrate the process of remote method invocation using a diagram, including all the components where client calls a method called generate report from a server. ටක් ගාලා කොලයක් කරන් බලන්න අඳින්න පුළුවන්ද කියලාද? එක්සෑම් එකේ full marks හම්බ වෙන diagram එක. Quick do it. So remember, you need to mention where is client, where is server. Possibly, okay, if I tell the answer is there, right? So you think and write. Look, if this is the question, what is your answer? And take 2 minutes. And if you have any questions, you need to get it clarified, okay? Right, so your answer must have the client stops, then the server machine, it must have the server skeleton, or you can call it server stub also, the server. Then you can label something like marshalling, unmarshalling if you need. Okay. Or even you can mention RMI registry. Right? I will mention the RMI registry also. Because otherwise, how can client look up? All the components where client calls method call generate report. Maybe you can even mention what classes you are going to have. Maybe class call my server. You can have the server interface. Then the interface must have this method. But anyway, they have not asked about the code, right? Just the components, okay? But maybe you can just list down some possible class names, okay? So that you can get the full marks. Right, so this is the examiner's answer. 2 marks for each component. So examiner has mentioned clearly this is client, this is server, and this is server, this is client. And this is your client object to the client program, server object to the server program. So examiner has used the word helper, but you can use client stub, server stub, or server skeleton. It's okay, right? Examiner has used helper. Okay, that's fine. So then the method call. It's a local method call here. It's a local method call here, but this is the remote calls. So examiner has not mentioned anything like marshalling, unmarshalling. So this is the minimum. But if you mention those, you may not get additional marks, but it's always good. Okay. Right. So this is the examiner's answer. Right. Do this one. So this is the C part. So this is a separate exam paper, 2022, paper 2, question 2C. Following diagram shows the calling of the method generate report, same method name, okay? In a remote machine, name the component label A, B, C, and D. So these are not MCQs. So what is A, what is B, what is C, what is D? What is A? Client or client object. In object-oriented terminology, we use client object. Or you can simply say client or client program or client object or whatever. B is the client stub. C is the server skeleton, or you can say server stub. D is the server or the server implementation or server object. Okay. Yeah, examiners use the word client object, but if you just write client program, you should get marks. But try to use the examiner's words as much as possible, right? The examiners use the word RMI stub. So that's fine, right? But if you just mention it as stub, client stub, you should get the marks. This is in 2022 paper examiners use the word RMI stub. But in the previous, right, it says client help, right? You can see even the examiner is not using the same words. So you should get the marks as long as it's you use standard terminology, right? Right. So therefore it's RMI stub or client stub. Here service. Now here you can see examiner use skeleton, right? Or RMI skeleton or server skeleton. Or sometimes we can use server stub. So then of course your server object or the server. Okay. Right. So do this one. Describe the reason to use remote method invocation RMI in Java application development. Explain with aid of the diagrams. Pretty much the same question they ask in different ways. So what is the reason for remote method invocation? Now, if you have a deep understanding, දැන් මම කියනවා අහන්නේ කියන එක නෙමෙයි ඔය. ඔයා මේක ගැන කල්පනා කරලා මේ examples කරලා දැන් මම පොඩි exercises දෙක තුනක් කරා keyword කරන්න කියලා object return කරන්න object parameter විදිහට දාන්න. ඒක කරනකොට තමයි ඔයාලට මේක ඇඟට වදින්නේ. එතකොට තමයි ඔයාලට question එකකට මොකක්ද අපි කියන්නේ? You can give sort of a matured answer. Right? Matured answer. So deep understanding. So that when someone read your answer can feel that, okay, this guy has a matured understand about this. This guy is not vomiting something this guy has memorized. Right? So you can either vomit something you memorize, so that is why some people, they hate to go to interviews. සමහරවිට ඉන්ටර්විව් එකට ඇවිල්ලා විනාඩියක් යනකොට අපි දන්නවා මේක ගිරවේ. මෙයා කටපාඩම් කරන් ආපුවා මේ කියනවා. සමහරව කතා කරනකොට අපි දෙනවා මෙයාට තියෙනවා හොඳ මැචියුරිටි එක. මෙයාට සබ්ජෙක්ට් එක දිරවලා තියෙන්නේ. ගිරවෙක් නෙමෙයි දිරවලා තියෙන්නේ. දැන් මෙයා මේ එයාගේ වචන වලින් උත්තර දෙන්නේ. එයාගේ concepts වලින් එයාගේ understanding එකෙන් උත්තර දෙන්නේ. ඒතර අපිට හැමතිස්සෙම අපි ජොබ් එකකට ගන්න අන්න එහෙම කට්ටිය. මොකද ගිරවුන්ගෙන් අපිට වැඩක් නැහැ නේ මොකෝ. එක්සෑම් එකක් දීලා පඩි ගෙවන්නේ නැහැ නේ. matured understanding එකක් තියෙන අයට පුළුවන් ඒ පැත්තෙන් තව ඉගෙන ගන්න, යමක් කරන්න, system build කරන්න. Right. So what is your answer? Describe the reason to use remote method invocation in Java application development. So the reason is when your method is in a remote machine or different machine in the network, you can't just call locally. So then you need to use remote method invocation. So explain with the aid of diagram. So again, you can use a client stub, server skeleton, server, RMI registry, and that kind of a diagram. But clearly show that those are two different machines, but connected through network. Okay. Right. If the calling and callee objects are in the same heap, heap means the same JVM. JVM knows where the objects are located and how to communicate with them. If the objects are in two different JVMs, that is what the question is, or two different machines, RMI is needed. RMI helps to invoke methods similar way that invoke methods on local objects. Explain with diagrams. So that means you need to explain things like stubs, skeletons, and so on. But this is a very minimal answer. Usually examiner will expect more detailed answer, right? More detailed answer with the help of a diagram.
So for this also we can draw the diagram that we drew before.
Sorry?
For this question also we can draw the diagram that we drew before, no?
Yeah, same diagram you can use. But it
Yeah.
must have the server stubs, client stubs, server skeletons, those things.
Okay.
And through arrows, you must show how these things are getting called. Okay. Right. So next question. It's a bit of coding, but examiner is not asking you to write the code. Right. Select the most suitable. This is MCQ question. Select the most suitable keywords for the blank A and blank B of the following code segment. So public interface bit exam extends this, public in get exam paper, int course code throws this. So this is the interface. This is the interface. So what should be the exception. So the exception is what? Remote exception, right? So then what should be what do you need to extend? Extends remote interface. And you are supposed to extend the remote interface, which is a marker interface, just like uh, uh, serializable interface. We mentioned about marshalling, unmarshalling. Marker interface කියන්නේ ඒ interface එකේ methods නෑ. Methods නෑ. හැබැයි JVM එක දට කියන්න ඕනවා. එතකොට මෙයා දන්නේ මේක remote කියලා. එයාට පොඩි signal එකක් දෙන්නේ. Method එකක් implement කරන්න. Right? So therefore it must be remote interface. And this is remote exception. If you are supposed to call a method remotely, make sure all these methods throws remote exception so that your stubs and skeletons can handle exceptions. So answer must be D. Okay, D. Is that all or any other question? Yes, one more question. This is another MCQ. Now you can do the 2024 questions. I have not included 2024 questions here. Answer question 3 to 4 using following diagram, which shows a client requests a service from a server. Again, select the correct statement regarding the component label B as B in the above diagram. So label B is this. Basically, it's a client stub. Client stub. Right, what is the answer? Anyone? What is the answer? So anyone? No one has given me the answer. Right, one answer.
C and E?
D and E. Two answers.
No, C and E.
C and D. Okay, anyone else? So one answer is C and D. I don't know whether multiple answers are possible. I have not checked that. Okay. Maybe multiple answers are possible. Any other answer, or are you agree with this? So do we have any other answer? D. So there's another one says D. Two different answers. Still you are very fresh with this topic, therefore your answers can be wrong. That is fine. Because we just did the topic, right? Right, so let's read it again. Right. Answer question 3 and 4 using the following diagram, which shows the client request a service from a server. Right. What is the correct statement? Select the correct statements. E is within the same heap. Okay, about the B. Right. So you need to, question is regarding B. E is within the same heap of the server. No, B is in the client. Right. This is the server. So therefore this is wrong. It doesn't have the method logic. Yes, right, because this is your client. Client has only the stub. Method logic is here. Sorry, method logic is here. Server method logic. So method logic must be in the server. Server implementation. So therefore it doesn't have the method logic, yes. Right? Method logic is here. Implementation is here. Gets the return value from the service. So the return value from the service. So from the service, you get the return value here. From here, you get it to here. In a way, correct, right? Get the return value from service. Service or server? Yeah, service. Yeah, if you take this as the service, you get the return value. I will say yes. Okay, I will say yes. Unpack the request from B. Remember, request is given from client. This is the response. So we unpack the response, not the request, because request is going like this. This is the response. So there, you pack your request or marshal your request. This guy unmarshal the request, then pack or marshal the response. So then this guy unmarshal the response. So therefore this says unpack. Unpack means unmarshal. Unmarshal the request is done by C. This will do the unmarshal the response. So you can see you must be very careful. Therefore, I will say no because it says unpack the request. Unpack the request is here. Okay. Invoke the real method. So the real method is invoked by this. This is the real method. So this guy invoked the client stuff. This guy invoked the server skeleton. This guy invoked the real method. Okay, so the server skeleton invoked the real method. So therefore, invoke the real method is wrong because this guy invoked the server skeleton, not the real method. I'll go for B and C. B and C. Examiner has not taken C. Why? Gets the return value from the service. Maybe examiner has considered this guy get the return value because I think this is the real service, right? Yeah, maybe that is why examiner has not taken C. Okay. But anyway, you are also getting, you can call this for entire thing also as service, but I think that might be the examiner's thinking. Okay. So shall we ask from ChatGPT also? Because, yeah, I'm not against the answer, but anyway, let's see. Let's see whether ChatGPT is also thinking like that. I'll say multiple answers are possible. Yeah. So ChatGPT also says only B. Okay, only B. No. Now ChatGPT says B and C. Okay. B and C. That is actually my answer also, right? I also thought it's B and C. But examiner has taken only B. Okay. So that is why I double check with ChatGPT. Because in a way, yes, right? Sometimes we can consider this as the server. So then the server uh, return value is get received by this. So therefore, yes, ChatGPT agree with me. Anyway, the examiner's answer is only B. I don't know why. Okay. Right. So what about the next one? Select the right. So same diagram but different question. Select the incorrect statement regarding the component labeled as C. Right. Do that. Labeled as C. So now they talk about the server skeleton. Right. Quickly do it. So these questions are not easy. Right. So now your task start. Think about these things deeply. Talk to ChatGPT, write more and more examples. Okay. So don't think that just listening to a lecture is going to work for you. No, it's not going to work like that for this kind of technical subjects. Sometimes you may feel like I have understood, but no, maybe not. Maybe still you have misunderstood things. Maybe on still you have confusions. Anyone? Don't worry if your answer is wrong, that is fine because we are just fresh to this topic, right? But at least give it a try. At least give it a try. Right, so one answer says D and E. Another answer says D. Right, so one answer says D, other answer says both D and E. Any other answer? Right, so let's see. Select the incorrect, okay? Statement regarding the component labeled as C. C is the server skeleton. It is pretend to be the service object. Yes. So, it is your real service object is server is this, but your stub call the skeleton. For stub, the object is this, but real object is this, but this guy is the object that your stub calls. So therefore, it's correct, right? It pretend because it is not the real service. Real service is but it pretends as the service because it can handle the complexity. B. Client calls the B, yes, as it calls the actual service. Client calls B as it calls the actual service. Again, actual service එක කතා කරනවා කියලා වගේ client call කරන්නේ ඇත්තටම B ට. Yes. So this is the actual service. But instead of call it the actual service, client call B. Client call B. Okay. But in reality, indirectly B calls this. So therefore, yes, client calls B as pretending it calls the actual service. Okay. So it's a little bit fuzzy, the wording, but it looks like okay, right? Client call B as if it calls this. As if it calls this, actually client call B. Okay. C. It is pretend to be the service object. It is pretended to be the service object. Correct, right? Because this is your actual service. Okay. It is pretended to be the service object. Yes. So C, pretend to be the service object. That is also correct for me. Okay. D. Is within the same heap as client. No. So this is not within the same heap as client. This is server. So that is wrong for me. It doesn't have method logic. Yes, it doesn't have method logic. Method logic is here. Okay. It doesn't have method logic. So therefore, I'll go for D. Okay. So both the answers you have D, but this answer both D and E, but E is not correct, right? It doesn't have the method logic is correct because method logic is here. So therefore, I'll go for D. So what is the answer? C. No, can't be C. Let me double check with the exam answer sheet 2022 paper 1. D. Bit semester 4. (2022) paper 1 question 4. Question 4 answer is C. How come C?
So A and C are same answers. Suppose.
It is pretended to be the service. Yeah, that is another problem, right? A and C are the same answers also. Okay, I don't agree with the examiner's answer for that. Okay, so let's ask from ChatGPT. So my answer is C. Just like your answers are majority's answers is also C. Okay.
D, sir.
Sorry, D. Sorry, D. Examiner's answer is C. Sorry for that. Okay. Okay, let's delete the answer. ChatGPT. Let's not influence ChatGPT. Now we'll ask ChatGPT. You are out of uploads. Okay, I will use my other account. Let's see what ChatGPT agree with me, us, or ChatGPT agree with the examiner. So our answer is D, right? A, B, C, D, E. So the final answer is D. The best answer is D. Okay. But notice A and C are also incorrect conceptually. They describe the stuff and not the skeleton. That is, remember, A and C are also incorrect. D is the wrong answer. Okay, let's double. ChatGPT is further confusing us. ChatGPT say D is the wrong answer, but A and C are also incorrect. Let's see. So let's see. So ChatGPT says D is the wrong answer. That is the first thing. That means ChatGPT agree with our answer, saying D is wrong. But ChatGPT further says A and C are also wrong. Why? It is pretend to be the service object. So they talk about C, right? Yes, right. Your stub is the one that pretend to be the service object. For the client, right? For the client stub pretend to be the service object, right? So remember, rather than you call this, you call this. So therefore, your client stub pretend to be the service object, right? Yes. So therefore, this is not pretend to be the service object. This for the client, right? For the client. So that is therefore ChatGPT is correct. This is also sort of a wrong. But anyway, I thought client is this, then this is pretend to be the service object. So therefore, both looks okay, right? But if you look at the client, your client stuff is pretend to be the service object, right? Anyway, it's very fussy. ChatGPT also has a valid point. And then what about this? It doesn't have the methodology.
So ChatGPT say A and C, not A and E.
Sorry?
ChatGPT's answer was A, C, not A, E.
Sorry. Sorry. Okay, let's double check. Yes, A and C are also wrong. Okay, so let's double check C now. A and
It's also
C.
the same statement.
So what is C? So ChatGPT agree with D, but ChatGPT says C is also wrong. It is pretend to be the service object. Anyway, these two are the same answers, right? Yes. These two are the same answers. So therefore, the ChatGPT's argument is By the way, if A is wrong, C is also wrong. ChatGPT's argument is actually B is pretended to be the service object. That is why client call it rather than client call this. Okay. Yeah, ChatGPT also has a sort of a valid logic there. Okay. But anyway, examiner's answer is completely different. Anyway, examiner's answer is C, right? Yeah, examiner's answer is C. Anyway, so the examiner's argument is also like that. But anyway, if C is answer, A is also answer. Right. So the examiner's argument is also this is pretend to be the uh, this pretend to be the server rather than this. So therefore, examiner says C is wrong. That ChatGPT also says, but ChatGPT says this is the clearly wrong answer. Okay. That is clearly the wrong answer, right? Is within the same heap is clearly wrong. So therefore, then maybe A is wrong, C is wrong because both are correct, same answer, and D is wrong. Okay. But I don't know, examiner has not taken D for some weird reason. Okay. Right. So any other questions? Yeah, one more question. Which of the following is accurate regarding remote method invocation? Right. Quickly do it. Accurate. Correct. Right. Let's quickly do it because we are running out of time. Because I have another class at 1:30. Right. Both the stubs and skeletons can reside in the same JVM. Yes, theoretically, yes, actually, that is what I did in the demonstration, right? But that is not what we practically do, but theoretically, no issue. Okay, no issue. So therefore, yes. But that is not the practical use. That is a different story. But this statement is accurate because it's a can reside. RMI can only pass primitive data types as parameters and accept such type as return values. No, you can have objects as parameters and objects as return. That is marshalling and unmarshalling. RMI makes it simpler to write remote Java servers and Java clients that communicate with such servers. Yes, because RMI generates the stubs and skeletons for you. Yes. The client helper is the client stub. In a JVM is called skeleton. No, that is called stub. Skeleton is server, right? Sometimes the skeleton is also called client. That's a different story. But the word skeleton is for server. Okay. The server helper in a JVM is called the stub. No, server helper is the skeleton, right? Skeleton. So the answer must be A and C. A and C. Yes, A and C. Right. So there's another question. What is the command line directive to run the RMI registry in Windows? So that is what we did today itself, right? Start RMI registry. Or RMI register or RMI registry. Registry, right? Yeah, start RMI registry. Yes, see. So we execute that command today itself. Right. One more question. Put up question, Dylan. What are the layers associated with RMI architecture? Remember above network, right? මතක transport තියෙන transport යට ඒවා අදාළ නැහැ. Data link layer definitely no. Data link layer is below. Network layer is below, right? Network layer is below. Net transport layer, yes. remote reference layer, skeleton and stub layer. අන්න එහෙම කතාවකුත් මට මතකයි. හැබැයි those are not official OSI layers. But definitely transport layer. එහෙම කතාවකුත් තියෙනවා කොයි හරි slide එකක හැබැයි. Those are not official layers. Remote reference, stub and skeleton, but those are not layers. But remote reference layer is there, right? Maybe we can take that also, but I think the examiner has not taken that. Stub and skeleton, those are not official layers. I Valentino. Yes. Right? Remote reference and skeleton and stub. So remote reference is about transport. Skeleton and stubs is above the remote reference. You can see here. Right? Remote reference, stub, client side, skeleton, server side. Transport, remote reference. From client, you have the stub. In server, you have the skeleton. Okay. Right. So, my question to them are current. Right. We'll stop at this point, right? Thank you.